All right, here we go. Day 2 for 2.2. 2.1 was, or excuse me, the first day of 2.2 was very easy. We just looked at end behavior, and it was very simple to know if the graphs, if they both went up, they both went down, or one side went up and one side went down. Had to deal with the degree, and it had to deal with the leading coefficient. Okay, very, very simple. I guess you could say that was kind of the appetizer of how to graph, which kind of just gets you started. The bulk of what we're going to do today, this is the meat and the potatoes of how we get all these graphs, is we're going to find the zeros for f of x. Now, we've actually already done this before. The zeros for f of x, this is where f of x equals 0. Okay, you guys can take this down, these 3 steps. Okay, you have that blank on your sheet. So we did determine end behavior. This is what we're going to do new today, 2 and 3. So find the zeros for f of x. That's just all the values where f of x equals 0. Well, remember, f of x is the same as y. So if y equals 0, then all we're finding today are x-intercepts. That's what we're finding. That'll give us that middle portion of the graph. Now, there's certain things that happen, especially when we factor. A lot of times to find the zeros of a function, we're going to factor. And when we factor it, we're going to notice a certain behavior for each 0. And basically what we mean for this, I'll give you kind of a heads up. We're going to kind of discover this on our own as we do these problems. This is basically when we graph an x-intercept, is there going to be a bounce off the x-intercept? What I mean by that is, let's say you get something, let's say you get x equals 2 to be an x-intercept. Well, if the graph is down low here, it could go straight through it like this, or let's say I erase this part. Or what could happen is I go up, and then it bounces off. So that's what we're going to look at. These two, steps 2 and 3, really give us that middle portion. We don't need the TI Inspire. We don't need the graphing calculator to get these. We're going to do these all by hand. And as I stated before, the key for doing all these by hand and finding the zeros, in most cases, is factoring. All right, okay, let's look at our first one. We're going to find the zeros. And then to kind of figure out what we mean by this, determine the behavior of each zero, the bounce, we'll first use the graphing calculator. So you can have the graphing calculator with you. Let's do it at the very end. Let's only use it at the very end after we get our zeros. All right, let's follow those 3 key steps. Let's first find the end behavior. For number 1, the degree is 4. So I'll put here, there's the degree, it's 4 right here. And the leading coefficient is negative. So I know right away this is my end behavior. All right, they're both going down, upside down parabola. So I did step 1. Let's find the zeros. So if I set this equation equal to 0, the key for this is factoring. Let's see here. I'm going to take out a common factor of negative 2x squared. When I take out negative 2x squared, then on the inside I'm going to have x squared. Now since I took out a negative, then this has to be a minus here. So it's going to be, let's see here, x squared minus 1. And then this, I'm just going to continue this down here. You have negative 2x squared. This x squared minus 1, well that factors, it's difference of 2 squares, it factors x plus 1 and x minus 1. So if this is equal to 0, I'm going to have 3 zeros here. For the x squared, well if you set that equal to 0, that's just 0. For the x plus 1, you get negative 1 for this one. And then for x minus 1, you set that equal to 0, you get 1. So this is kind of the new part that we did today. This is going to give us the middle portion. All right, now what I'm going to do, before we even do step 3, that's going to be new. We're kind of discovering what that means, step 3, to determine the behavior at each zero. All I'm going to do right now is I'm going to graph these 3 zeros. So if I have x equals this, 0, well that's the origin. I have x equals negative 1, so it's right over here. And x equals positive 1, that's right here. So all 3 of these are real close to each other. Then what I'm going to do is I'm going to use this end behavior. Now this is just a rough sketch right here because we're not using the graphing calculator yet. I know this is the end behavior right here. To get this graph, the middle part, to match up to the end behavior, at this point I would take this, put this in your graphing calculator, and see what happens right there. All right, so put it in your graphing calculator right now and see what the graph looks like. You can pause it, and then we'll go over it. All right, so hopefully you did that. Hopefully you put the graph in there. And if you look at the graph, it kind of goes up here, and then when it comes down to, it kind of looks like an M shape. When it comes to the origin, that's where it bounces, and then it goes straight through, and it matches up with the end behavior. So it kind of looks like an M. If you couldn't see it here, you might want to zoom into that. It does go above the x-axis, but here's the main point. Put this in a different color. Let's put this in red. Here's the main thing right here. At here, there was a bounce. And that's at x equals 0. So this is where there was a bounce. And for the corresponding factor for that, the degree was 2. All right, just keep this in mind. Here your degree is 1. Here your degree is 1. And it went straight through. You might even know the connection already. Okay, let's do number 2. Now number 2, when we do this is less work for us because it's already factored out for us. It'll just take us maybe a little bit more work to get the end behavior because you kind of have to see, you have to add the exponents together to find out the degree, and you have to figure out the leading coefficients to get the end behavior. All right, so if I look, since it's all factored out, I'm going to add all the exponents. This is 2. It's assumed to be a 1 right here. This is assumed to be a 1. So if I add these 2, the 1, and the 1, the degree is 4. Now the leading coefficient, well, this is going to give me, what, an x squared. This just gives me an x. This negative, well, that's raised to the first, that's negative x. When you multiply all these, it gives you negative x to the 4th. So it's going to look like number 1, where it's going to look like an upside down parabola. So that's our end behavior. So that takes a little bit of work. All right, I'm going to erase this, what I just did. And now we're going to find the zeros. Well, here's a good thing. Everything's factored out. So if I replace f of x with 0, well, for this one, we get x to equal 1 for that factor. Here, we get x to equal 2. And the 3 minus x, we get x to equal 3. So, again, I'm doing nothing with the graphing calculator. I'm going to graph these points 1, 2, and 3 on the x-axis. So they're going to be real close to each other. So let's go 1, 2, and 3. Then I'm going to put the end behavior in. Here's the end behavior. So these both go down. And again, I'm just putting them to the left and to the right of these 3 intercepts. Okay, then if you graph this, okay, again, right now you can stop the video, put this equation on your graphing calculator, on your TI Inspire, and what you want to ask yourself is, out of these 3 points, where do you get a bounce? Where does it bounce off of it? So you can do that right now. Okay, hopefully you did that. You graphed it. And when you graph this, there's only a bounce at one place. It's at x equals 1. So the graph looks something like this. It comes up, then it bounces off. Okay, it comes down just a little bit, and then it goes above just a little bit, and then down, and it matches up with the end behavior. All right, so let's summarize this again. Let's put the bounce in here. Let's put this in red. This point at x equals 1, this was the only bounce. And when we got x equals 1, it corresponded to this when our degree was 2. So you should kind of start seeing that when your degree is 2, like here it's 2, we got a bounce here at 0, here our degree was 2, we got a bounce at x equals 1. The other ones, it just went straight through. All right, see right now, stop the video right now and see if you can do number 3 on your own. And at this point, you probably can figure out where you're going to get a bounce at the 0 and where it's going to go straight through the x-axis for the zeros. So do number 3 right now on your own. Pause the video. All right. So hopefully you did number 3. When we do number 3, our degree, let's see here, our degree is 5. Everything's positive. So this is going to look like an S shape. It's going to go down to the left. It's going to go up to the right. So I'll do this in red. Our zeros, well, for this x squared, I have x equals 0. For this x minus 2, I have x equals 2. So let's graph this. I got the origin, and I have x equals 2. I'm going to put the end behavior in, which is this. So to the left of the x-intercept, I go to the left. To the right of the last x-intercept, I'm going to go up to the right. Now when you graph this, and you do this on your own, you're going to notice this, let's put this in blue now, the bounce you're only going to get at the origin. So your graph looks like this. It goes to here, it bounces, comes down low, and then it goes straight through x equals 2, and it matches up with the end behavior. All right, here's the main thing. This is the summary right here. When everything is factored out, and you can't factor anymore, if this exponent, if it's even, this is where you get a bounce. If this is odd, like I could change this to just 1, 3, 5, 7, then it goes straight through that corresponding 0. So let's put this in right here. So summary for behavior at the zeros. If x minus a raised to the k is a factor of f of x, this k is really important. We say if k is even, then there's a bounce. It bounces off the x-axis. We'll say bounce off x equals k, because x equals k is x equals, it's going to be a. So it's going to bounce off of where x equals a, which is the 0. If k is odd, then it goes straight through the x-axis. So we'll say crosses, let's put here, crosses x-axis at x equals a. All right, let's just do one more. Let's just do number 4, and then number 5 you guys will do on your own. Okay, and let's use this. So this summary right here, this is step 3 for when we looked at the steps 1, 2, and 3, how to graph these by hand. This goes over the behavior at the zeros. All right, let's do number 3 together. All right, we're going to do everything, end behavior, zeros, and see if there's a bounce or if it goes straight through. All right, this, it's not factored out, but it makes us easier to get the end behavior. Degree is 4, leading coefficient's 3, so it's going to look like a normal parabola. That's our end behavior. They both go up left and right. To find the zeros, we're going to factor. It's not factored out for us. We could take out an x cubed. Okay, if I take out an x cubed, then I have 3x minus 4. And then to get the zeros, for this, I have x equals 0. And then for this, you're going to add 4, then divide by 3, so you get 4/3. Now, to figure out, you do step 3 to figure out if there's bounces. That's 3, so there's no bounce here. And then this is assumed to be raised to the 1, so there's no bounce. So there's no bounces at all off the x-axis for these. Okay, let's graph this. We have 0, and then we have 4/3, which is 1 1/3, so it's a little bit past 1 right there. I'm going to put the end behavior. These both go up. Now, when I come down here, they're going to go straight through everything. Go straight through, and it matches up like that. Now, it might not actually look like that. It might look like a perfect parabola. Mine's kind of off a little bit, but I don't care. I mean, what I want you to know is how to get the general shape of these graphs just by doing simple factoring, knowing the end behavior, and knowing the behavior at the zeros. All right, so I'll just leave off on that. Always follow those 3 steps. Get the end behavior, set f of x equal to 0, find the zeros, and then once you factor everything, if k is even, and another thing I forgot to mention here, it's written here, k basically means multiplicity. You might see that in your textbook. It'll say, well, what's the multiplicity? Well, if the multiplicity is even, there's a bounce off the x-axis. If the multiplicity is odd, or if k is odd, then it goes straight through the x-axis. All right, so do number 5 right now. We'll go over this in class tomorrow.